Welcome to MIPI DevCon 2020. Thanks for joining. We're glad to have you with us today. Feel free to engage with the presenters and attendees by using the engagement tools at the footer of your screen. Click Q&A to engage with presenters and group chat to communicate with the attendees. You can simply minimize or maximize each of these icons with one click. To see the agenda, sessions, and demos, click on the Call to Action icon. Enjoy the conference.
Hi, I'm Justin from Mixel. Mixel was founded over 20 years ago and has been a leading provider of mixed signal IP since 1998 and a contributing member of the MIPI Alliance since 2006. We were the first IP provider to demonstrate silicon for D-PHY, C-PHY, and M-PHY. And today, I'd like to show you two of our customer demos, both from Microsoft. The first is the Microsoft Azure Connect Developers Kit, and the second is the Microsoft Hololens 2. Both feature Mixel's D-PHY IP.
The Microsoft Azure Connect Developers Kit is an edge device with advanced AI sensors for sophisticated computer vision and speed models. It's designed for versatility. It combines an advanced depth sensor and spatial microphone array with a video camera and orientation sensor, with multiple modes, options, and software development kits. Mixel's MIPI IP was integrated into the depth camera, which features a time-of-flight imaging chip with advanced pixel technology. This enables higher modulation frequencies and depth precision, all in the world's smallest time-of-flight pixel, at 3.5 micrometers by 3.5 micrometers. To enable this LiDAR camera, Mixel provided Microsoft with our D-PHY CSI2 TX IP. This IP was provided as a completely integrated solution, with the controller coming from Northwest Logic, a Rambus company. This IP runs at 1.5 gigabits per second per lane, with an aggregate data rate of 6 gigabits per second with 4 data lanes. But since then, Mixel has also developed a 2.5 gigabits per second per lane, and most recently silicon-proven our 4.5 gigabits per second per lane D-PHY. This IP provides an aggregate bandwidth of 18 gigabits per second and was the world's first MIPI D-PHY version 2.5 specification compliant IP available from an IP provider at this bandwidth. Now, taking a look at the demo, we see three different views: the infrared camera, the depth camera, and the normal video camera, and we'll focus on the depth camera because that's where Mixel's IP was integrated. Now, the different depths are represented by different colors. As we get closer, it gets bluer. As we get further away, it gets red, and black is where the LiDAR camera can't get a reading. Right now, we're looking at the 2D view, and we can switch this to a 3D view, which will show the image in a 3D environment. Keep this view in mind when we look at the HoloLens 2, because the HoloLens 2 uses the same depth camera for object placement around us in our environment. One last point: while this shares the same product name as the Microsoft Xbox Connect, the Microsoft Azure Connect is an extension of the Connect line of sensors, and is a standalone device that works with a Windows or Linux-enabled PC.
So now let's take a look at the Microsoft HoloLens 2, which uses the same depth camera we just saw in the Microsoft Azure Connect Developers Kit. If you look at the device, you'll notice it's self-contained. The processor, battery, sensors, camera, microphone, lens, all built into this headset. This is a perfect example of MIPI being used in a high-performance, low-power use case. Unlike a VR headset, where I don't need to wear my glasses because the screen will be right in front of my eyes, the HoloLens is actually projecting the image at a distance, so I'll keep my glasses on for this part of the demonstration. Now let's take a look at some applications using the Microsoft depth camera that features Mixel's IP.
Alright, so let's take a look at the HoloLens. You'll notice that the depth camera recognizes when I place my hand in front of it, and it will overlay the menu icon on the inside part of my hand. So let's go ahead and bring up the menu. And we'll select 3D Viewer, which is a collection of 3D objects. This comes standard with the HoloLens. It's a collection of different objects so developers can kind of get a feel of what's possible with the HoloLens. Now these are all stored on the cloud. Right now we're connected to the Wi-Fi, so I'll go ahead and download the model, Bubblegum. You can see how easy it is for me to manipulate these objects, but in the lower right hand corner you'll notice I'm just touching air. So you can drag, drop, rotate, and manipulate the object like you would on a touch screen. Alright, so I'll go ahead and pause this and get rid of this. The HoloLens comes with a couple of different applications standard. Check email, your calendar, you can bring up a web browser. When you use any sort of application that requires a keyboard will pop up, and you go ahead and select. Now there is the option to use the voice command feature, but since we're focusing today on the depth camera, I'll be showing the use cases that require using the depth camera. So that includes the keyboard, the touch. Now you'll notice the screen stays put, it's anchored in the real world. Now this is one of the key differences between augmented reality, which overlays the image, and mixed reality, which is anchored into the real world. The camera just went and scanned the room to make sure I was still in the same room, to make sure I was still in the same place. If we go to the other room, before I started recording this demo, I placed a lot of 3D objects. And you can see that the camera automatically recognized that I had switched rooms, and it remembered where these objects were in the room next door. So if I point my palm and pinch my index finger and thumb together, I can do a distance touch or an air touch. I can also still drag and drop and move this painting, which is on the wall around the room. So we can go ahead and pause this. A couple different 3D objects that I've placed here. See some animals in the corner. Again, I can pinch and drag and drop from a distance. If we look over here, you can see some furniture I placed earlier. This is a good example of a use case for the HoloLens too. If you were an interior designer, or an architect, or in construction, or realtor, and you wanted to show a potential customer what the environment would look like, or what the end product would look like, you could do this with the HoloLens too. Another example of a potential use case could be the medical field. If you were a surgeon and you needed to call in a specialist and you wanted them to see what you're looking at, you could get their opinion in real time, have them see what you're seeing with your own eyes, and overlay any image or annotations or patient charts or other information similar to a video call, but all done through the HoloLens too. Another potential use case is if you are a mechanic or a technician, or maybe you're an engineer on an assembly line and you needed to work on the fly. You could grab your HoloLens 2, put it on, and have the display overlay a system diagram or provide a virtual view of inside the equipment you're looking at. With the right software, maybe it could even tell you the part number of the piece you're looking at, and you can order that part from within the HoloLens 2 itself. So that about wraps up the use cases I wanted to share with you today. There are other applications that come already available in the Microsoft App Store. There's a game, for example, that's pretty fun that we can try out next time. Really, though, this device will only be limited by the developers and their imaginations as they create more and more applications to be available for the HoloLens 2. Putting on this device really feels like we're in the future, and it's a very exciting piece of technology. And Mixel is proud to play a key part of this device. Thank you for listening today.